Let's consider the next question of this paper, that is question number 7. Let S be the set of all triangles in xy plane, each having one vertex at origin and other two vertices lie on coordinate axis with integral coordinates. This is clear. If each triangle in S has 50 square unit as area, then the number of elements in the set S. So let's understand the drawing first. That is, let's draw the coordinate axis, that is x-axis, y-axis, and just draw a triangle like this. Correct. Now consider this point is a comma 0 and this is 0 comma b. For the time being, I am considering both A and B in the first quadrant, that is A is greater than 0 and B is greater than 0. Clear? Now half AB, since both are positive, no need of writing modulus over there, is equal to 50, or product AB is equal to 100, which can be written as 2 square 5 square. Now how many factors we can see over here? We can clearly see the ordered pairs. When you try to make it, it will give you 9 factors are there. See, when I talk about the ordered pairs, I can simply write the ordered pairs like when you start with 1, then 100 is there, then you say 2, then it is 50, 4, then it is 25, then 5, it is 20, 10, 10, 20, 5, 25, 4, 50, 2 and 100, 1. So this way you can see clearly 9 ordered pairs formed when you have taken in the first quadrant both A and B. Now you can also consider in the similar fashion in the other quadrants, like you can move to the second one, third or fourth. Correct. So you can see 9 are obtained everywhere. It's simply going to give you final result as 36. So it is available as option number 3. I am sure this question is clear. Let's move on to the next, that is question number 8. Let f be a differentiable function from R to R such that mod fx minus fy less than equal to twice of mod x minus y whole to the power 3 by 2 for all real values of x and y. F0 is 1, we have to find integral 0 to 1 f2x dx. So let's plan this question. I can rewrite the given inequality as fx minus fy upon x minus y whole inside the modulus symbol less than equal to 2 times mod x minus y raised to the power half. Now when you take the limiting case for it, like limit y approaching to x, what will happen? You will simply write here f dash x, its modulus is less than equal to 0. Modulus can never be negative, so the simple conclusion over here is f dash x equals 0, that is fx equals constant function. I am sure this part is clear. One more condition given, that f0 is 1. So when you put x equals 0, you get f0 is equal to 1, meaning the function is finally concluded as fx equals 1. So that's the function, fx equals 1. Now the question says integral 0 to 1 f square x, so that is simply 1, giving me 1 as the result. I am sure this is clear how we are getting the solution for it. Let's see from the given options. Yes, it is available here as option number 1. So let's write down the correct answer here as 1. Right. Let's move on to the next question, that is question number 9. X is sine inverse sine 10 while y is cos inverse cos 10. We have to talk about the value of y minus x. Simple question from inverse trigonometry. X equals sine inverse sine 10. Now my requirement is basically to see this term in the interval of minus pi by 2 to pi by 2. When I talk about 10, I can say it is 3 pi plus something, because 3 pi, that is 3 into 3.14, that is 9.42, correct. So when I talk about the quadrant system like this, right. So when you are talking about 10, meaning pi, 2 pi, 3 pi plus here. So we have 3 pi plus something. So let's write it as 3 pi plus 10 minus 3 pi. Now taking it as theta, sine 3 pi plus theta is minus sine theta. Sine inverse of minus sine x is simply minus outside. So we have here minus sine inverse sine 10 minus 3 pi. 10 minus 3 pi is a number in the interval of 0 to pi by 2. So the result is directly obtained 3 pi minus 10. This is the value for x, correct? Let's talk about y. Y is cos inverse cos 10, meaning cos inverse cos 3 pi plus 10 minus 3 pi. Although for cos we can also go with 4 pi, that will give us result fast. But here we can write it as cos inverse minus cos 10 minus 3 pi. This is clear? Now cos inverse minus cos x, we can write simply pi minus of something. So we have pi minus 10 minus 3 pi or 4 pi minus 10. This is equation number 2. Now the question is talking about y minus x. So let's find the value for y minus x over here. Therefore y minus x is 4 pi minus 10 minus 3 pi minus 10. I am sure this is clear. 10 is cancelled. We are simply left with a simple term that is called pi. So let's see the given options. We have pi as option number 4 available over here. So let's mark and write it down. This is clear. Let's move on to the next question, that is question number 10.